Have you ever come across with the situations like this? If you are in a train A and it came to a station and stopped, and after some time there's a train B that is also came into the station and stopped, and after some times the B departed from the station with a small velocity VB. Then you are in A and you see that the B is moving. Yeah, and you say, hey B, you are moving. Then the passengers in the B say that no, we are not moving. You are moving in the opposite direction with a velocity VB. Then the person in A, that's you. You are saying no, you are moving, but they will not accept that. They are saying that you are moving. So who are actually moving in this scenario? We know that the B is moving, but why should the people inside the B say that they are not moving? That's the thing. That's where the relative velocity terms come. If your friend is moving on a car in this direction with a velocity VA, and you see that a ball is moving down with a velocity VB, and my question is, how would be the path of the ball would see by the person inside the car? Yeah, you may say that it has velocity in the downward direction as VB, but from the frame of the car, this ball is moving in this direction with a velocity VA, because the both of them are moving, so there's a relative motion. He should see that everything else in the universe is moving in the backward direction with the velocity same as the velocity is moving. So the velocity of the ball as observed from the car is the sum of these two velocities, and if you find out the velocity of the ball with respect to A, that should be equal to V of the ball plus minus V of the A. This is the relative velocity concept, and it is a velocity that of the ball when it observed from the car. Let's suppose there is a ball here and you are the catcher here and you need to catch this ball to win the match. Let's suppose the ball has a velocity of VB in the downward direction and you are running in this direction in order to catch the ball with a velocity V. Then my question is, how do you find the velocity V? Well, you say that this distance, if you taken as D, and this distance if you taken as H, then you can find the time at which the ball reached the ground, and you need to calculate the velocity by dividing the time with this distance, then you get the speed in order to catch the ball. Yeah, that's a good answer, but that's not happens in the real world. In real world, the man will look at the ball from his eyes. He always points the ball's direction to his eyes like this way. How? Let's see. If he moves in this direction with a velocity v, then ball should have a velocity of v in this direction as from his frame. So the net velocity will be like this. So every time he decreases the speed or increases his speed according to this direction, he is making this direction to him always, and whenever he reaches this point, he can get the ball. That's how he is catching. A real man is catching like that way. This is one of the application of relative velocity. Suppose a girl is moving in a bicycle with a velocity Vg in this direction, and at that time the rain comes, and the velocity of the rain is in the downward direction. My question is, in which direction should she hold her umbrella to protect herself from the rain? Yeah, she's moving, so she's moving in the velocity Vg in this direction. So she see that the rain particles is moving in the opposite direction with the velocity Vg magnitude. That's why she need to hold her umbrella in somewhat like this direction, in which this component is Vg and this component is Vr.